Hello dear students, welcome to EPG Pathshala. I am Dr. D.C. Saxena, Professor and Head of the Department of Food Engineering and Technology at Sant Longowal Institute of Engineering and Technology, Longowal. I am presenting you the paper Technology of Meat, Poultry, Fish and Seafood Products, and in the present module you will be given the knowledge of canning and irradiation of fish and seafood by my co-author Mr. Narendra Kumar Chandla.
Hello students, welcome to EPG Pathshala. I am Narendra Kumar Chandla from Sant Longowal Institute of Engineering and Technology. Today I am going to talk about module 32 of paper number 8, that is Technology of Meat, Poultry, Fish and Seafood. In this module, we will be discussing about fish canning and the irradiation techniques. We will talk about canning as a preservation technique and its advantages in terms of retaining the quality after harvest to till consumption of the fish and fish products. The canning process is a sterilization technique that kills microorganisms already present on the fish, prevents further microbial contamination, and inactivates degradative enzymes. In this process, fish are hermetically sealed in the containers and then heated to a high temperatures for a given amount of time. Canned fish can be stored for several years. However, sterilization does not kill all the microorganisms and bacterial growth, and the gas production may occur if the products are stored at very high temperatures or above than the 50 degrees centigrade. Various food products like salmon, sardine and tuna will be discussed, and their canning techniques have been explained in this module. Fish irradiation techniques known as radurization for the preservation of the fish and the fish products will also be discussed. By the application of radiation, movement of the free radicals increased with increase in the temperature, affecting the overall rate of radiolysis, reduces the production of the volatiles in the food products, which are made up of fish and fish products are of the meat products. In this module, we will talk about thermal destruction in the canning, thermal resistance of the microorganisms, canned fish products, process state for fish canning, fish irradiation, fish radurization, radiation doses, and we will talk about the potential application of the irradiations. Canning and irradiation process. The canning process is a sterilization technique that kills microorganisms which are already present on the fish and prevents further microbial contamination and inactivates enzymes by the application of canning through hermetically sealing the container. In this process, fish are hermetically sealed in the containers and then heated to the high temperature for a given amount of time. Canned fish can be stored for several years without refrigeration. However, sterilization does not kill all the microorganisms but reduce the load of the microorganisms to a subsequent level so that it could be fit for the human consumption. The bacterial growth and the gas production may occur if products are stored at very high temperatures. In canning, thermal conditions, for example, filling, clinching, exhausting, double seaming, cooling and retorting at a temperature of 121 degrees centigrade causes death of the microorganisms, and this is integrated with the prevention of the oxidative changes. In this case, exhausting is applied so that vapors may be generated inside the can, which takes out the gas out of the cell of the fish, and during cooling they get condensed and subsequently generate a sufficient vacuum inside the can so that it could have its structure against the high temperatures and variation in the altitudes. Canning and irradiation process. In canning, the most common types of fishes which are used are tuna, salmon, herring, sardines and shrimp. The thermal processing does not have a detrimental effect on the high quality protein of the fish. In addition to this, the species are often canned with their bones left intact. The bones become soft and edible upon thermal processing and significantly increasing the level of calcium present in the fish products. Tuna is an exceptional case because of special handling considerations. The bones of the tuna are removed prior to the canning. Tuna is normally caught for offshore and must be frozen and held for some period of time prior to the canning. During this freezing and holding period, unsaturated fatty acids are oxidized, causing the tuna to become rancid. The rancidity is removed by pre-cooking, and the bones are removed at this time in order to facilitate the cutting and preparation of the meat for the canning. Thermal destruction in the canning. Thermal destruction of the fish-borne bacteria that is imparted by the heat treatment or the heat supplied. Heat treatment is required for the destruction of the bacteria present in the fish prior to its marketing and consumption. Adequate thermal process for particular time is given to eliminate the pathogen bacteria or the pathogen microorganisms, particularly Clostridium botulinum. The thermal process time which is supplied to the retort is 121 degrees centigrade or even higher, so that the fish during the storage may remain preserved. This thermal process is called the F value or the lethal rate. In the canning, food is divided into three categories, and the categories are on the basis of the difference in the pH. The pH may be high acidic, medium acidic or low acidic, depends upon the species of the fish or the fish products to be canned. Thermal destruction in canning. As we have discussed the effect of the pH and the effect of the pH in terms of the fish to be stored or the product to be stored. Foods are categorized as high acid below 4.5 pH, medium acidic pH 4.5 to pH 5.3, low acidic above pH 5.3. Here we will talk about high acid. Fish marinade and pickles containing acetic acid, citric acid or lactic acid will not support the growth of the non-spawn forming bacteria and other pathogenic microorganisms. In medium acidic pH, which ranges in between 4.5 to 5.3, tomato sauce filled fish product fall under this category. They require full heat sterilization treatment for the destruction of the microorganisms which may be present in the fish after or before canning, like Clostridium botulinum. Low acid pH above 5.3. In this product group requires a full sterilization treatment, as do the medium acid group. It may be noted that extremely heat-resistant spore-forming thermophilic organisms could survive such a process. For example, thermophile Bacillus stereothermophilus. And this particular microorganism have been found responsible for the flat sore spoilage of the canned foods. To eliminate such microorganism, if heat is increased, then it would overcome the fish spoilage. So, it is observed that combination is due to the raw material used like spices and herbs which may contain these organisms. Therefore, contaminated raw material like spices or the herbs which need to be added should be eliminated during pre-processing conditions. Thermal resistance of the microorganisms. The thermal resistance of the microorganism that may be affected by the various factors, the destruction of the microorganism and inactivation of the enzyme is due to the heat supplied for a particular time, and subsequently denaturation of the protein may occur in the fish. Therefore, a particular time and temperature and the other factors need to be controlled and monitored so as to prevent the denaturation of the proteins. There is a great variability in degree to which different microbes resist heat process for their destruction. Therefore, the lethal effect on the microorganism may need to be calculated before the canning process, or more specifically for the retorting of the fish and fish products. There is effect of pH, salt, nitrite, water activity, organic acids and antibiotics on the destruction and inactivation of the enzymes during heating. The most heat-resistant microorganism is Clostridium botulinum, which is generally found in the processing of the canning. The heating process of the canning is, as discussed, is validated in terms of the lethality of the microorganisms at different temperatures and at different pH. Canned fish product. In this, the canned fish products are small pelagic or sardines and similar products. Small pelagic, these fishes are not heat processed but packed in the dry salt and subsequently sealed in the large cans. A degree of proteolytic ripening occurs through storage, and product is frequently sold in this form. Anchovy fillets, however, are removed from the whole fish after salting, packed in the oil and heat sterilized like canned fish. As per as sardines and the similar products, these are called Norwegian sardines and labeled as bristling or sealed and are most frequently packed and brought in the frozen form. Hand packing of fish into can is a laborious work. The flow sheet for the processing of the canned fishes is shown in the figure 32.1. Other fishes like tuna and mackerel, Crustaea and Molluscs and new canned fish products have also been shown in the figures. Here we will talk about tuna and mackerel. The pre-processing of scombroid species is carried out in steam under atmospheric pressure for times that vary according to the size of the fish. Therefore, the size of the fish need to be graded before canning. The mackerel are often cooked in open can, which is followed by decanting of the separated liquor, sauce or oil injection, sealing and retorting. Tuna are cooked and allowed to cool for up to 24 hours to set and become processable. They are then cleaned and trimmed. In this process, the removal of the head, spine and dark flesh underlying the lateral line. All skin must be removed, facilitation of the packing, and remaining flesh is packed as a solid stick, as chunks, and as flakes by hand or automated machines. In the later two cases, this involves molding the pieces into correct shape, cutting, and then compressing them into can. Subsequently, dry salt is added, which is followed by oil if an in-oil pack is required. The sequence is completed by topping up the container with the sauce and then sealed and processed. The finished product contains about 60% fish and 40% sauce. A typical flow sheet for tuna canning have been shown. Canning of tuna fish. In this, the frozen fish is thawed, pre-processed for evisceration, cleaning, and then inspection was done. The pre-processed fish is cooled, cleaned, and trimmed for further process of slicing and head filling. This can be done either manual or by automated machines. Addition of salt and oil was done before exhausting, and then seaming, that is double seaming of the can done before retorting. The retorted can were then cooled, labeled, and stored at ambient temperatures till the final uses. The fish preserved by this method can be eaten for years. Crustaea and Molluscs fish. Shrimp used for canning are normally in medium to very small size. After removal of the head and shells, the fish is blanched for 6 to 10 minutes at 100 degrees centigrade in 11 to 13% of the brine solution. This causes the flesh to shrink and curl and subsequently produce the desired characteristics in terms of the flavor and color. Shrimp meat is hand-picked into cans, or it may be through machines. Then the picked shrimp meat or the fish is topped up with 7 to 8% of the brine solution. Pre-cooking is, however, is not carried out in the hot water or steam. A flow sheet for their production have been discussed above. Here we will talk about the flow sheet of the Crustaea and Molluscs. In this, depuration, cleaning and inspection of the fish was done. Blanching was done so that to inactivate the enzymes like peroxidase and catalase for 2 to 4 minutes. Then opening of the shell or shucking, that is the cell removal, is done by vibration. Then next process was given is deep frying, which was done for 1 to 2 minutes. After having the application of the frying, the fish is subjected for the process of the exhausting. As we have talked about, exhausting is a process where steam is applied at a temperature 89 degrees centigrade for 8 to 10 minutes. Then the product exhaust is seamed. That means the product which is inside the can is further sealed, double sealed. Then the canned product is facilitated for labeling and packing. Then the product is stored at ambient temperatures, or even some of the pigments like carotenoids may be added so that there is subsequent reduction in the discoloration of the carotenoids present in the fish and the fish product. Then cooling and subsequently retorting at a 121 degrees centigrade for 15 minutes was done. The product is then stored at ambient temperatures and labeling was done. The product would have a shelf life of 12 to 24 months, or it could be more if it is stored at elevated temperatures. Fish irradiation processing. Fish irradiation essentially is a non-thermal process of preserving fish because the treatment does not cause any significant rise in the temperature. Temperature of the product being irradiated has an influence on the radiation induced changes. Movement of the free radicals increased with increase in the temperature, affecting the overall rate of radiolysis. Lower temperature reduces the production of the volatiles in the food products, which is known for the effect of sensory quality of the irradiated foods. Such changes are at a minimum in the frozen products, as these products are stored at lower temperatures. Fish radurization. As far as radurization is concerned, it is the application of radiation to the foods using a dose of ionizing radiations, which is sufficient to enhance its keeping quality by causing a substantial decrease in the numbers of viable specific spoilage microorganisms. The required dose is in a range of 0.4 to 10 kg for a range of food products. Radurization processes have been developed for a variety of fishery products, including marine, freshwater, and shellfish. Radiation process depends upon many other factors, including initial quality of the fish, that is the raw fish, dose of the irradiation, packing conditions, and the temperature during the storage. Ideally, the fish should be of highest quality for maximum benefits. Aerobic packing has been found satisfactory for several low and medium fatty fish species because of vacuum packaging of the fresh fish, and had several disadvantages such as oozing of the drip or possibility of outgrowth of the Clostridium botulinum under adverse storage conditions. Therefore, aerobic conditions need to be removed during the packing. Irradiation doses. As radurization process have been developed for variety of fishery products, including marine, freshwater, and shellfish. These are summarized the extension of the shelf life due to irradiation, which depends on several factors, including initial quality of fish, irradiation dose, packaging conditions, and storage temperatures, as discussed. Reduction of the spoilage microbes to improve the shelf life of the meat, poultry, or seafood under refrigerated conditions. Irradiation dose required in a range of 1.5 to 3 kg for meat, poultry, and seafoods. Elimination of the pathogenic microbes in fresh and frozen meat, poultry, and seafood requires a irradiation dose in a range between 3 to 7 kg. Potential applications of irradiations. Under refrigerated conditions, shelf life extension of the fresh fish and elimination of the pathogens in fresh and frozen seafoods is sought. Individual quick frozen fish and reduction of the pathogens, including viruses like hepatitis A, from oysters, recorded with the application of the irradiations. Other potential application includes shelf life extension of the fresh fish under refrigeration, elimination of the pathogen in fresh and frozen seafoods, hygienization of individual quick frozen shrimp, reduction of the pathogens including viruses from the oysters, development of the shelf life products from fish, removal of off odors from some species of lobsters and oysters. Reduction in the fecal coli forms live hard shell comes. Last is hygienization of the fish meal, which is achieved by the application of the irradiations in the described range of the ionization radiations. Summary. So, in this process, fish are hermetically sealed in the containers and then heated to high temperatures for a given amount of time. Canned fish can be stored for several years without refrigeration at ambient temperatures. However, sterilization does not kill all the microorganisms and bacterial growth, and gas production may occur if products are stored at very high temperatures, or if there is a lacking in the preservation technique, especially in the handling of the cans. In canning thermal conditions, for example, exhausting and retorting at a temperature of 89 degrees centigrade and 121 degrees centigrade respectively causes death of the microorganisms, which are integrated with the prevention of oxidative changes. The most common types of fishes are tuna, salmon, herring, sardines, and shrimp. Fish irradiation is essentially a non-thermal process of preserving fish because the treatment does not cause any significant raise in the temperature and have better flavor and taste values, while radurization is the application to the food irradiations to foods using a dose of ionizing radiations, which are sufficient to enhance its keeping quality by causing a decrease in the number of viable specific spoilers microorganisms. So students, let us now summarize what we have learned in this module. In this module, we have learned about canning process. As we know, canning process itself is a preservation technique. In the process of canning, we come across with the process of shorting, filling, exhausting, then retorting, and then we should have an intermediate process of cooling of the fish. So, if we talk about the canning of the process, it is automatically a process in which fish is hermetically sealed in the containers and then heated to the high temperatures for a given amount of time. In canning thermal conditions, for example, exhausting and retorting at a temperature of 89 degrees centigrade and 121 degrees centigrade respectively causes death of the microorganisms integrated with the prevention of oxidative changes. As we know, oxidative changes will be reduced by the application of the creation of the vacuum during exhausting and subsequent cooling of the cans. Types of fish canned are tuna, salmon, herring, sardines, and shrimp. Fish irradiation is essentially a non-thermal process of preserving the fish. In this module, we will be learning fish canning and irradiation technique. We have talked about canning as a preservation technique and its advantage in terms of retaining the overall quality of the fish after its harvest to till the consumption of the fish and fish products. Canned fish can be stored for several years without any refrigeration and could be stored at ambient temperatures, but higher temperatures may result deterioration of the quality in terms of production of the gas inside the can. However, sterilization does not kill all the microorganisms and bacterial growth, and the gas production may occur, and this production in the gas may result the inferior quality of the canned fish products. Various fish products like salmon, sardine and tuna have been already discussed, and their canning techniques have been explained in this module. Fish irradiation technique, radurization for the preservation of the fish and fish product will have also been discussed, and we know the irradiation having its application in the preservation of the fish. But there may be a rise in the temperature, and this may affect the overall rate of radiolysis, and the radiolysis is gone at lower temperature so as to have lesser production of the volatiles out of the food products, and especially in the case of the fish. Radurization is the application to the food radiation to the foods using a particular amount or a dose of ionizing radiations, which is sufficient to enhance its keeping quality by causing a substantial decrease in the number of viable specific spoilage microorganisms. That is all about fish canning and irradiation techniques which are required in the case of the preservation of the fish and fish products. Thank you.
So dear students, now you know about the canning and irradiation of fish and seafood, which has been explained by my co-author. Now in the next module, you will be given the knowledge of value-added fish and seafood products like minced fish, surimi, retort, processed fish curry. Thank you.